So, good afternoon everyone. I'm sorry I wasn't able to be presenting live. Something urgent came up that I need to take care of, so I'm going to record this yesterday. I did record it yesterday. And I'm going to talk about something I haven't talked that much about ever, I think. Basically my journey towards sustainable geodesign. Normally I do talk a lot about projects and cases, so this is something completely new for me. Since I'm not here live, you're of course always welcome to reach out by LinkedIn or by email, which will be there a bit later. I'm very honored to have the ability to talk at the ICE conference. I'm very happy that Matthias asked me to join. But yeah, let's get to it. My journey towards sustainable geodesign. So the agenda is about me, a bit about me and a bit about my company that I work in, called Ramble. Some of the tool and concepts that I've been using a lot of time with and what I'm using today. And then I throw in a case about the Danish Technical University that I want to briefly talk about, and then some of the learnings that project basically gives, just some small learnings about it. About me, my name is Kenneth Lindhardt. Hopefully I did say that in the beginning, but now you know if I didn't. I have a daughter on 14 and a son on 11 years old, and this is last summer, just outside of the heart of Copenhagen. There's a festival called Copenhagen, and especially me and my daughter, we do like some good guitar music with a lot of noise. My son, he likes to wear his sound blocking things on his ear. I don't think that he thought it was the best experience in his life, but maybe he will grow into it. So I started out just after I left school, 15 years old. I started as a bricklayer, which I think is a bit odd in my industry. I've been working as a bricklayer for 9 years. Before I basically had a bad knee and back, so I started to go into a new education called Architecture and Construction Management with the profession of facility management. So that education is more like the glue between architects and engineers and the client at the end. Try to understand all the languages and build something buildable. Right now I'm working as a senior GIS consultant in Ramble. And if you have no clue about what GIS is, that is something that I will talk about and try to explain. So my company, Ramble, is based, the headquarters is based in Copenhagen, just 15 minutes from where I live. It's an old engineering company in Denmark, and the largest from Denmark, where we have more than 18,000 experts working with basically creating sustainable solutions across all the markets. We have a lot of architects, engineering, and then people like myself. We are in 35 countries, and we have around 300 offices around the world. And as you can see, we are based just outside of the nice city of Copenhagen, where we in Denmark do like to bike a lot. So a lot of our projects includes a lot of biking tracks. And especially a lot about the sustainable environment that we are experts in. And as you can see, we do cover a lot of the world with our offices, all the way from Australia to the West Coast in the US, and then of course in the middle of Europe, where we do have a lot of offices around. I think in Denmark we have around 5 or 6 offices, We are a pretty small country compared to many other countries. So in the very beginning, when I started my education, I got very excited about BIM. And BIM stands for Building Information Modeling, and basically it is an object-based 3D model. So for everything that you create in the model, you are able to extract the data. That could be, for example, in this building that we see right here, you have windows which contains glass, so you will be able to calculate how much glass. You will also, in that way, be able to calculate how much the weight is, so how should the construction be built, how much wind flow should there be, and how many square meters and stuff like that. I did like that approach because you had the great design capabilities directly inside of your building software, and you were able to create a data flow where you used one single source of truth, which was great for me to be able to export all of that data, so you actually knew what you were building and you could plan for it in the project. And then BIM just had some really good visuals from the very beginning when you designed the building. When I finished my studies as an architectural and construction manager, I was hired by a company called Informi.js, which is the Danish distributor of Esri software, the ArcGIS toolbox, you can say. And basically that is the software that I'm using today to do my daily work. So when I started out, I saw some of those GIS maps, and again, if you don't know what GIS actually is, that is geographical information systems. So it is to place information geographically, and you maybe know it from Google Maps, or where you can search for a coffee shop, and then afterwards you can take the route, the fastest route to get there. And that's basically GIS data that is used for doing that. But we do use GIS to a lot of other stuff, like calculating demographics, where do people live, what is the age, so we know what to build and how many customers we can get into an industry that we are designing or something like that. So basically it's just geolocated data. And GIS is really good at doing geospatial analysis to understand what is the distance between different things, how many people are living in the areas, and some of you maybe have seen the COVID-19 map that was very famous at some point, where you could see how many incidents there were globally, and you can see how many people were vaccinated in each countries and stuff like that. And the great thing about these things is that the analytics and the visuals makes us understand all of that big data inside of GIS. And then, like BIM, I like the GIS because it has a data flow where you had one single source of truth. You collected all your data in one place, and then you shouldn't have your data laying around on a hard drive and they have multiple copies of that. But did the visuals actually met my needs for when I came from BIM anyway? It was a bit boring to see some of those GIS maps, but I started to test it out when I started working for the Danish Esri partner, now called GeoInfo. When I started working with GeoInfo, I could see that maybe maps could do a bit more of the visuals that I missed from my BIM days. It wasn't just dots on a map, basically. It was a lot more than I thought it would be. And you could actually create some very nice looking maps that also gave you some information at the same time, and a better understanding for the human brain. the big issue with the human brain is you cannot comprehend all of the data in a spreadsheet, but as soon as you place it on a map, you can see the density and you can kind of like understand what is going on in the world. I also found out that actually GIS does use a lot of 3D data like I was used to from the building information modeling from the BIM. In this case it was, for example, point clouds. You can see the density of, or the elevation of the world. So we have the entire Denmark scanned with a point cloud like this, so we know exactly where is there a tree, where is there a building, and what is the height of those things. So the game changer for me in the GIS industry was when I saw a presentation from Geert van Maan from Esri talking about how they use GIS to create the Pixar movie Cars 2. Basically that came to that conclusion that what I wanted to work with was that tool of software that was used to create exactly that movie, and hopefully one day work at Disney. I think there's a long way yet, but still it could be quite fun. So basically what you can see here is in the background, that is a GIS map with the data and information about how the building is designed. And those data and information is then used to create the city in the background. So that basically is a 3D model driven by data. You can use lines, that will be the street, right? You use points, that will be the trees, and you could use the building footprints to create the different building types. So for example, the buildings, that could be something like the height of the building. As we saw before, we could actually extract that directly from a point cloud. We could add the building age to kind of like create the design of the building, and then the usage. So you would probably know that a residential building would look a bit different in architecture than a hospital and stuff like that. And the same goes for streets, where you're able to say something like if we want to create a boulevard, or how wide should the pavement be, or something like that. Then you could basically use that data to develop the 3D content of your city. And what we are using to do that is called procedural modeling. So basically we are trying to call it more like a data-driven modeling, but the real word is procedural modeling. So what is procedural modeling actually? So it's a set of rules that creates 3D models and textures. So you can think about it like an Excel spreadsheet. If this is true, then do something. If it's not true, then do something else. So if we say that that this street has the data information, this needs to be a boulevard, then we will create trees in the middle. You can always afterwards, you can always create first random content on that street. Maybe we don't know where to place the car, but we could just say place 10 cars somewhere on the street. But you will also be able to change the rules parametric, like you can see on the left on this small video. That by changing, basically manipulating the data, then you will be able to create new design scenarios. One of the great things about this tool that we're using here is that you will be able to extract all of the data that you're creating. So all the models will have some faces, some geometry that you will be able to report on afterwards. So this is a very simple explanation on how the rules are working. You have the rules to the left, and this is almost in Danish. So this is the height of a building, and we are splitting this up into a front yard, and then you have the building. Over here you have the parameters. So right now we are creating this as a 50-meter tall building. and we are reporting on some of the area is red, and the entire area is something else. So when we start to develop those rules, we're able to subdivide it further and create new information and new data. So this is still a very simple building, but right now we have extracted the facades, the roofs, and the front yard of the building. So basically the outcome is a 3D object GIS model. So maybe you remember in the beginning I was talking about BIM would create 3D object models. It's a single model you can click on and it will give you data on that model. It's not like when we see a mesh or see like Google Earth or something like that, where you just have like a blanket of buildings, which looks nice by the way, but you're not able to go inside and then extract the data from a building. You get the possibility to change the parameters, and you always have one single source of truth, because this system is pulling all of the data out of the GIS data that I showed you before. So if you had that building footprint saying that this building is 20 meters high, you have that from a database connected to your GIS data, then the buildings will be 20 meters high. And that's why you can basically create an entire city at once, like they did in the Cars 2. And then at the end you get all of the reports, which is something that you will need to do sustainable planning. So how was this used how are we using this for procedural? How are we using procedural modeling for sustainability analysis on the Danish Technical University in Denmark? So we're using all of these GIS data. We had the elevation, as I showed you before, the point cloud to create the building height, and we had the building footprints because that is something that we have nationally. We did have some client data about new buildings, and then we used some satellite imagery to calculate the different materials going on the ground to find streets and pavements and trees and stuff like that. So a brief story about the Danish Technical University. It's a very large university. I think it's the biggest one in Denmark, I'm not sure. It's placed in Lyngby, just outside of Copenhagen. It's on 111 hectares as far as I remember. And they stand in a situation, although that they are big, they do have a lot of students, and they know that the students will have even more students in the future, so they are going to expand a lot on that area. And they wanted to use a sustainability scheme called DGNB, which is very famous in Denmark. It's a German scheme, and it is used to both to calculate how sustainable your buildings are, but also the environments around your buildings. So to be able to create to understand how sustainable the area is, we needed to subdivide the entire area into the parts of the materials for the DGNB reporting. That could be something like if you wanted to know the biofactor, which basically tells you something about how much green area is there, how good is the green area. The better the green area it is, the more points you will get in your final report, if you compared it to asphalt buildings and stuff like that. So that's why we needed to know exactly the materials of the areas, how many square meters buildings, how many trees we had, and then we needed to use that into the report. And when we are looking into that system, as I said before, we are extracting all of the GIS data. So when we are building up something like this in the Danish Technical University, we are actually not modeling anything. We are using the rules and then the data. And as soon as we run the information, then we or run the tool, then we get the information about that for the new area we have built 1 million square meters of building area, and the biofactor is in fact on 47. I'm not an DGNB expert, so I have no idea if that is good or bad. I think it was pretty good. It was they had a good certification at the end. But sometimes you maybe don't know what the material actually is. Maybe you don't have the data, and that's when you have the ability to use the parametric changes. So we didn't have the data for the outside area of this place. So if we added some green areas, forest area, then you could also see that the biofactor would change. So you could actually see the consequences of your design while you were modeling it. And that was on a larger scale of the area, but you were also able to go down to the specific building plot, the lot that you were working with. And that could be that you wanted to see how would it benefit the biofactor if we created like a green roof instead of just having an asphalt roof. And instantly you will be able to, first of all, regenerate the building so you can see the new design, but you will also be able to see the biofactor update. And of course you could see the total area of how many building square meters we have, and then what is the size of that building we are looking at right here. Although it is best just to use the real data, then sometimes you just don't know the design. Maybe it's a future building or something like that that you want to design on. And I know that in the Danish Technical University they had some lots where they wanted to make sure that they honored maybe 30% of green area in that lot, and then the rest could be building the building footprint. And that's why we created a tool where you would be able to update the building design in many different ways, and always have a look at how is the biofactor, how is the area of the buildings, do we live up to what we have set on in the master plan. So there was a lot of different design possibilities. You could change different, create like a terrace area of your building, but also change the different facade designs that you could choose from, and especially the materials of your buildings. And that has something to do with the global warming effect of your facades. The more black your building is, the more heat it will produce when the sun reflects to it. So that was also something that we needed to take into account when we were designing these rules, and we wanted to see how sustainable they actually were at the end. Because sometimes you can look at a model and you can like the black bricks compared to the white bricks, and maybe they have some benefits about another place in the DGNB certification, but in some cases maybe it will produce a lot of heat, and you will need to take care of that. So the ability to just see the same design with different materials and understand how it would actually look and feel when you walk down to the buildings, but also use the reporting at the end to get more knowledge about how it will actually work in the area. So some of the key takeaways for this project that I found was very interesting was that it was live updatable. You can see it was very easy to go around with the parameters and just change the building design, change the building heights, which was needed because this was a very large project. And it was amazing to be able to sit directly with the client, as we're doing right here, and listen to what they had to say, and then instantly update the building or the design and see how it actually looked in real life, doing some visualization of it, and see how it would affect the biofactor or the DGNB certification. It also made it very easy to communicate all of the data that came into this model, because you could actually visualize the complex data in a way that that everybody could understand when we were in the meeting. We couldn't lie with the data, we couldn't throw something under the floor or something like that. Everything was visible, which is something that also created a lot of benefits in understanding where the errors was in the data, because if you had wrong data, it would show in the building for sure. So it did create a lot of data quality. We did update a lot of the data for the DTU campus because we could actually see where the errors were. And then one of my favorite things was that of course we did use one single source of truth, because if you are copying your data everywhere, then you forget to update something, and the best thing is to avoid to make the human mistakes. So if you can use the data and you can use the computer to do the most of your work, so you not have to update your spreadsheets and stuff like that, then it will be very, very valuable at the end. So that will be what I'm going to talk about today. I thank you so much, and thank you so much for the opportunity to come and talk. And the tools I've shown in this presentation has especially been a lot of the CD Engine, which is the procedural modeling tool, and then everything is tied together with the ArcGIS platform. And at the first thing with the building information modeling, I did show you building from Autodesk Revit. Thank you so much.